Yeah, thanks. So today we will actually discuss about the blockchain basics, means what are the characteristics of the blockchain and how we can apply it in our real use cases for the life science industry. So to know about the blockchain, we first have to know the characteristics of the particular technology, that why this technology is currently in so demanding and why it is saying that it is a disruptive technology. So that thing we will cover first. So let's move to the slide number 2. So first of all, we will discuss about what is blockchain. Then after that, we will discuss that why is it relevant for our business, specifically for the life science industry, and how can IBM help us to apply the blockchain, means what are the initiatives are being taken for in the blockchain space by IBM, that I will discuss. So let's move to the slide number 3. Okay. So blockchain is basically one architecture, and blockchain is a kind of reverse engineering. So whenever we know the term about the blockchain, we have to understand that what are the specific parties, what are the specific pillars involved inside the blockchain. For that, 3 things are very necessary. First of all is the business network. Second is the asset or wealth. Third one is the market, that is the public or private. So the network is very necessary. Blockchain operates in a particular network where different participants, customers, and different business parties are involved in a single system. So you can think about a big system or a big network where different business parties are involved and they are operating, they are doing business among each other. Then we can identify that, okay, so this is the business network, how the things are happening from business party 1 to business party N. So that first thing we need to identify that what is the business network. The second thing we need to identify that what are the assets which is flowing through this particular business network. That asset identification is one of the key factors whenever you are going to use any kind of or you are going to work in any kind of blockchain use cases. The second point, that is the asset, is very important. You have to identify. So for example, if I am giving that assets can be different types. Suppose there is a food industry. So we can consider the food as one of the assets. So assets can be 2 different types. It can be tangible asset or it can be intangible asset. Another example I can give the mobile number portability system in case of telecommunication sector. So here the mobile number is one of the assets. So these 2 things first you need to identify whenever you are going to use the blockchain technology, that is the business network, and second one is the asset. The third point is the market. So I have mentioned the third point, that is the public and the private. So I will discuss more about it, that we need to identify that a particular business network is applicable in a small system, in a private system, in a permissioned one, or it can be a public one where it is no permission is required. If you have your identity like ID and password, you can access that public network. So these 3 things are the main pillars whenever we are going to learn about the blockchain, that we need to understand: business network, assets, and the market. Let's move to the slide number 4. Okay. So here you can see that it is the slide about the transferring the assets and building the values. As I have mentioned that asset identification in any case of blockchain use case is very important. That is tangible asset and intangible asset. Tangible asset is suppose there is a house, and intangible asset suppose there is a mortgage. Okay. And there can be different divisions also possible for the intangible assets. So once you deep dive into the blockchain, you can understand that which asset is going through, which assets life cycle we are talking about. Then we have to go to the more granular level for that particular asset. Okay, so still now I have not entered into the blockchain technology. I am describing the pillars of any business, pillars of any network, that so that you can understand that whether blockchain can be applicable to this particular use case or not. So these things you need to first identify in case of any network. So this is all about asset. Let's move to the slide number 5. Yeah. So now the blockchain came. So now we have to identify that what is the problem in case of current business network. So we can see that there is a big business network available in any system. Okay. So from business party A, B, C, D up to n number of business parties are available. Each business party will have different ledgers, there are different systems in their own system. Okay, they have different ledgers. So if business party D or business party E wants to take wants to look at what happens whenever there is a transaction between business party A and B, they cannot see, because the ledgers are only confined to that particular business party. And if we want to see, or if we demand that, okay, I want to see the ledger, what the transaction happened, whether you have given something wrong information or not, we cannot see. Or they can tamper their own ledger, they can provide the false information. So different kind of scams we have seen, like 3G scam, etc. Whatever be. So whatever be the information is given by them, we have to abide by, or we have to get into some kind of investigations that whether they are correct or not. So that is one of the problems currently exists. So ledger, as all we know, it is the system of records, and system of records which contains different transactions. Whenever any business party is doing any business with another business party, that is called one of the transaction. And in input and outputs are associated with that particular business party. So ledgers, what they store the input which is coming to the business party, output of the business party, and the transactions which they have interacted with other different business parties. So these things are stored into the ledger. Now we have to understand that why the ledger is very necessary. So as I have mentioned, that ledgers have this kind of problem. Different parties have different ledgers. So there is a problem exists that there is no transparency between two business parties. I cannot claim that yes, your ledger is perfectly correct, or we need to go through different kind of investigation. That's why it has mentioned that ledgers are the key. So if we can build such a system in which everyone should have a shared ledger which is replicated among different business parties, then there should be some kind of transparency. Okay. Now one question may arise in your mind that, okay, so if I share my ledger, everyone has the same copy of the ledger, then where is the privacy? There can be some kind of privacy associated whenever I am transacting with another business party. Yes, that thing also has been taken care of by the blockchain. They provide this kind of technology, that is the shared replicated ledger technology, where everyone will have the same copy of the ledger, but with some permission. That yes, if I have the permission to see this portion of this ledger, then I can see it. If I don't have the permission, I cannot see it. Now suppose some dispute arises, and I claim that, okay, I want to see the transactions, but I don't have the permission. Then I claim for that particular permission, and with proper permission, I can see that transactions. So that's why the ledgers are so important nowadays, that to provide the transparency among the business parties. Next point, the next important thing is the contract. So contract I will describe that here in blockchain technology, we have some kind of smart contracts. In the later slide, I will describe about it. Going to the next slide. Okay, now introducing blockchain for the business. So this slide is shared replicated permission ledger, what I have described. Now again I will describe in the slide number 7. Yeah. So in the slide number 7, as I have mentioned right now that every business party has different copies of their system, and they have different data structures, different things available, different databases. So it is inefficient, expensive, and vulnerable. Everybody is maintaining different structure. So there is a lack of trust, and obviously it is very inefficient, whatever I have mentioned in the previous slides lecture. So that same thing has been depicted over here, the problem. Going to the next slide, the slide number 8. Here, it is nothing but every participant in the business network have been joined into this blockchain network. So they actually share the ledger that replicate that particular ledger has been shared between different business parties, and everybody has same copy of the ledger. And this particular ledger is not only the characteristics of the blockchain, that yes, only the shared replicated ledger I have, I can see everything with proper permission. That is one point, that is the most vital point. But apart from that, what are the things the blockchain technology has been providing? That is the consensus, provenance, immutability, and finality. These 4 characteristics are very important nowadays. In case of nowadays in our world, the trust is the most vital issue. Means whenever we are outside our home, if any family member is there in our home, we feel safe. But if there is any stranger in our house and we are outside the house, then back of the mind, always in our back of the mind, we think that yes, there are some stranger in our house. There can be a chance that there can be a problem in my house, or there is always a tension behind the mind. Okay, the same case is for the business also. Whenever I am joining in any business network, I am doing any business with some big business parties. So back of the mind, I want to be ensured that my ROI, my return on investment should be good. I should not be cheated. There must be some kind of transparency among us. So if the network is characterized by the blockchain network, then they can think, okay, so I will have the shared replicated ledger with my in my machine or in my cloud system. Then nobody can cheat. If I demand something that yes, you have cheated with me, then this ledger is the proof, because every transaction will be logged into the ledger, and the ledger is immutable. So now the 4 pillars, the 4 main characteristics I am going to describe apart from this shared ledger, that is the consensus, provenance, immutability, and finality. So let us go to the next slides. Okay. So first of all is the consensus. Consensus means the agreement. So agreement between different business parties. So suppose there is a business network where the 4 business parties are involved, A, B, C, and D. Now there is a business going on between A and B, and for that particular transaction, that yes, A is doing some business, some transaction with B. For this particular transaction, suppose there is a need of approval from the business party C. If C approves and B approves and A approves, at that time that we can consider yes, this transaction is successful. Okay. In current scenario, suppose A and B are doing business among each other and they are talking among each other. They are saying that okay, so if you do this business with me and you do not tell C, and so I will give you this much of rupees, give me this deal, I will make it, in a kind of business network. So there is a chance of fraud in current scenario. So the consensus means in case of blockchain technology, whenever A, B, and C will be in the business network, there should be some kind of rules associated between A, B, and C, so that for a particular transaction must be A, B, and C must abide by this particular transaction. Okay. So now, yeah. Okay. So next, go to the provenance. So I will come to the consensus in more detail, because consensus is one of the most characteristic feature of this blockchain technology. I will discuss it in more detail. Now next come to the provenance. So provenance means this is the proof. This is nothing but the proof that, okay, I know that how the asset life cycle has been transferred, what are the transactions happened between one business party to another business party. There is a proof, and the proof is in the ledger, and that ledger store all the information regarding the transactions, regarding the inputs and outputs, everything. So for that, we can consider the ledger information as a provenance of our business network. This is the proof, and this provenance is characterized by immutability and finality. So why this is proof, why I can consider this, or any legal authority can consider the blockchain transactions as a provenance, as a proof, because it is immutable. You cannot change anything inside the shared ledger. Once a transaction has been done, it's done. Nobody in the business network can change or remove it. I will come to it, that how the immutability has been achieved inside the shared ledger of blockchain technology. But the characteristic is this: it is immutable. As it is immutable, so it is the great proof that yes, the transaction happened and it has happened, and it is the truth. You can consider is a source of truth. So that is the provenance. Another thing is that in case of blockchain, while doing the blockchain system or working on any blockchain use case, you first have to identify the asset, as I have mentioned, that what asset is flowing between the system. There can be several assets associated in a particular business network. You have to first identify it. And these assets are going from one stage to another stage. So we consider it as an asset life cycle. So how this particular asset life cycle has been changed? While we are drinking some kind of soft drink, okay, then we are paying some money, but we don't know that whether that particular soft drink is worth that amount of money or not. But if that system is in the blockchain technology, we can see that what transaction has happened. We can have that traceability information for that particular product. So this is the provenance, that the traceability information we can have via scanning the QR code or different methodologies. We can have the full traceability information. Customer can know that how and when this product has gone through, in which stages of life cycle. This is the meaningful information. Not all the transactions, everything is definitely not, but some meaningful information will be provided to the customer, and they can trace using the blockchain technology that about that particular product. The last point is the finality. Finality is the keyword, is one of the characteristics, that everything in one place. In a full business network, you need not to search to all the systems, all the business network to get a particular information. Only one place, that is the shared replicated ledger. You can find the transactional information and the input, output, everything. So that is the main definition of finality, that in one place only. Okay, so let's move to the next slide. Yeah, so the next slide almost is same. The four pillars, whatever I have described, that is the shared ledger, and three things extra. It is also associated with that four characteristics, that is the privacy, proof, and the smart contract. So the next important thing is the smart contract. Now I will describe about another very important characteristics, that is the contract, smart contract. So in case of any business, whenever you are doing business with one party to another party, then there must be some kind of contract between them. Now suppose very simple example of contract, that if I give you $5, you will give me 1 pen. Okay, so this is the contract between you and me. Now, this contract is in English language. So there can be some kind of ambiguity. If you write the contract in a legal paper or something that this, there can be some kind of ambiguity because English language can be interpreted as different way. There can be some business parties written in some kind of clever way that there is a dual meaning. So there is a problem associated with that. But in case of blockchain, every contract that if I give you $5, you will give me 1 pen, it will be encoded in a programming language. And that programming language is unambiguous. It does not have any kind of random functionality. Okay, so like that way the programming language evolved. For blockchain technology, it is unambiguous. So it has only one meaning. Whenever you will code that particular contract in the programming language, it has only one meaning. That is why that contract is called a smart contract, because it is smart enough to produce only one result. If this, then it will happen. If this, then it will happen. There is no dual meaning. So that is the smart contract, and I have given one example of the smart contract. Next point is the privacy. So privacy, because there are certain level of cryptographic measures available inside blockchain technology, via which it ensures the privacy. That yes, if you want to see this transaction, you have to upload your wallet file, you have to upload your identity card, then you can see this transaction. There are some access control rules also present inside blockchain technology for the permissioned one, for the permissioned blockchain technology. But you can think that yes, there are certain level of privacy that okay, if there are some confidential information, confidential transactions is going on, and we don't want to reveal that particular information to one of the business party who is not that much associated with us or doing some other kind of business. So that kind of privacy is also available inside blockchain. So you can think like inside IBM, sometime if you want to see some kind of data, some kind of training material or something. So if you don't have was that particular manager role, you cannot see it. So there is a certain level of privacy associated with it. In the same way, here blockchain also we can define that particular privacy via some cryptographic measure and the access control rules inside blockchain. And the proof is nothing but it is another term of the provenance. And here you have seen another term that transactions are probably endorsed by the relevant participants. So the endorsement, the new term we heard over here, this is also another granular level characteristics of the blockchain technology, that is the endorsement. So we will see that what the endorsement means. An endorsement is closely associated with the consensus. I will describe. So right now we have covered the 7 to 8 characteristics that why blockchain and what are the features associated with the blockchain, this part. Going to the next slide, that is the slide number 11. This is the shared ledger. So I can say this is the shared system of record. So whenever anyone is saying that what is blockchain technology, then definitely the answer will be the replicated shared immutable ledger. So that is the characteristics of the ledger, not only the shared ledger, replicated shared immutable ledger. So that characteristics possessed by the blockchain. So shared ledger, everyone knows that it has been shared. How it has been shared, I will describe in the consensus model. Next is the smart contract. So smart contract, I have described that the same business rules encoded in a programming language. And it has some characteristics that is verifiable and signed in the slide number 12. So it is verifiable and definitely it is signed one. Okay. Why it is signed? Because It has some internal characteristics. While we will go deep dive into the blockchain technology, we will see that to create one transaction, we need to provide some kind of e-certificates. So that e-certificate has been provided while we will join into the blockchain technology as a participant. So it is like, you can think like a user ID and password, or some kind of private key file which is being provided by while we are going to connect to the Google Cloud or etc. So in the same way, you can think that if you want to do some kind of transaction, you first have to register, and after you register, then you will get some kind of e-certificates, and using that e-certificate, you have to invoke all the transactions. That is why it is called the signed. And why it is verifiable? Verifiable is again associated with that particular term called endorsement. So endorsement I will tell, but right now you can just understand that it is a signed smart contract, and it will be verified. That contract means anyone can invoke the transactions, and that transaction happened and stored into the shared ledger. It is not that case. It must be verified by different endorsement policies between different business parties. Okay, that is why it is a verifiable. Okay, examples I have given, and it is encoded in programming language. Going to the next slide, slide number 13. Next is the privacy. Privacy, the same thing, that there is a certain level of access controls available inside the blockchain, and everybody cannot see everything inside a private permission network. Everybody cannot see everything. You need to have proper permission. You need to contact them. You need to have that particular certificates. Then only you can see that transactions, or you can invoke that particular transaction. Last point is the cryptography central to the processes. So here everything is cryptographically secure, starting from the business network building, and the certification authorities are there who will provide different certificates to the different business parties, and using that certificates you have to do the transactions. Nobody can just blindly come and do the transaction. You need to have proper cryptographic certificates with you. Next point is the point number 14, proof. This point is achieved through the consensus, provenance, immutability, and finality. So the proof is that it is a kind of provenance, and all that functionality what I have described, that is the consensus, provenance, immutability, and finality, everything actually contributes to the proof. And there are some points you can see that participant endorse the transactions. So again, we encounter the term endorsement. So let us discuss about the endorsement over here. So participant endorse the transaction. So endorsement policy is a kind of policy that you need to define while you are deploying the that particular chain code. Now there are different parties available, right? Different parties available inside a business network, and you are deploying one chain code. One chain code means it is a chain code in terms of blockchain. We are telling you can consider it is a normal programming file. The smart contracts, whatever I have described, the smart contracts we have written, and that programming file, that particular .go file or that particular JavaScript file is called the chain code. So that particular chain code we are deploying into the business network, means we are installing inside it, just like a normal C code compiling or something like that. Okay. But during that particular deployment, there is an option that we can specify that who will endorse this particular the transactions for this chain code. Now suppose there are A, B, and C. Three business parties are available, and we have decided that whatever be the transactions written inside the contract, it should be endorsed by A and B or C. Like that, there are different combinations are possible during the endorsement. So endorsement means that we are taking that particular thing that okay, when A agrees, A should agree to this transaction, B should agree to this transaction, C also should be agree to this transaction, then only that particular transaction will be stored, means that particular transactional payload will be stored as a block inside the blockchain. Okay, so that is the endorsement policy. So different endorsement policies we can define while we are doing this blockchain network, depending on the use cases. Okay, so this is called the endorsement, that we need some kind of agreement, some kind of consent from that particular business party while doing this particular transaction. Okay, and next is the assets have a verifiable audit trail. So audit trail is obviously possible because everything while the asset life cycle is going on, what happens to that particular assets, how it has been modified and transformed, every transactions will be written into the shared ledger. That's why it has a verifiable audit trail. And obviously, the next thing is the traceability. So traceability is nowadays a very burning problem. So blockchain really can help. IBM and Walmart are conjointly doing that food traceability solution. So that traceability information is very important, and via blockchain and this proof and provenance characteristics, definitely it is possible nowadays. But there are big challenges also there to trace a particular product, but yeah, it can be possible using blockchain. Okay, so the next slide we are going, it is slide number 15. You can see it is a full version 1 transaction life cycle. So this is the internal picture. This is the internal picture of the blockchain technology, specifically the Hyperledger. So Hyperledger is one of the platform which actually describes the blockchain architecture. Hyperledger is a blockchain technology. So IBM is mostly focusing on this Hyperledger technology. Hyperledger is a open source provided by Linux Foundation, and IBM has contributed to this particular blockchain technology. And internally, I have mentioned the consensus is very important. Consensus means the agreement between different business parties are very important. So this slide actually depicts the internal working technology, that how they agrees that yes, A, B, and C are the three business parties, and they are telling that okay, I agree. He tells I agree. So how it actually happens? So in a very nutshell, if you can see this particular slide number 15, then you can see there are different peers available. So peer is again a technical term, whenever any business party will join this network, any business party will join their network, then they can be considered as a peer. So one business party have to provide different peers, like different computers, you can say, means without technical, if I can describe it, then you can say that different computers, different virtual machines are considered, different containers are considered as a peer. Okay. So from the application, now suppose the application SDK, means you can consider it as a front end, So from the front end, suppose A want to do business with B, and from the front end, A has submitted some kind of transaction. So this is called proposal in case of Hyperledger Fabric. This is the version 1. So application sends the proposal to the peers. Now peers can be defined as two different terms. Means while we set up the business network for a particular business party, then there are some configuration files available. Inside that configuration file, we have to mention that how many peers we want for our business network. Okay. Now there are a lot of transactions are happening, and we want to tell that okay, so we need 3 to 4 computers if there is a problems occurs, then so that if one peer is down, then second peer can take care of that particular transaction. Okay, so this is the thing. This is a cluster of peers. So more when you deep dive into the technical, you can see that different peers setup can be possible, and we can actually give the name one peer as endorsing peer, other peer as the committing peer, like that. So in a nutshell, if I say that peer, I have described in a two different manner. Like one is endorsing peer, another is the committing peer. So committing peer actually put the block into the blockchain network. The finally it actually logs the transactions into the shared ledger. And the endorsing peer, what is the working of the endorsing peer? Endorsing peer actually executes the chain code and creates a read-write set. And a single computer can do the both the things. Means if I define that, okay, I don't have that much money, I want to join the business network, I will expose only one system, then only one peer will work as the endorser and also the committer. But definitely in the production environment, we need to have different peers if you want to join that business network. So how the flow occurs actually? So I am just telling in just 2 minutes that from UI it sends the proposal, and as I have mentioned, while deploying that particular chain code, we can define the endorsement policy, that who will actually do the endorsements, from which business parties we need that that particular thing, that yes, they agree, A agree, B agrees, and C agrees. They are called the endorsers. So while the UI, from the UI, someone invokes that transaction, then that proposal will go to all the endorsing peers associated in the endorsement policies. And that endorsing peers will execute the actual chain code. And while executing that particular chain code, it will create the read-write set. So what is the read-write set? Read-write set means, suppose before this transaction, the asset have some state of its life cycle. So that is the read state. That particular state before the transaction, whatever is currently associated, what are the parameters, what are the field values of that particular asset. Now suppose I am telling that there is one asset, suppose called like what a simple example. Okay, let's take the mobile number portability. So mobile number portability, so in case there is mobile number is one of the assets. So in case of mobile number, there are different fields associated, like the number, who is the current holder, who was the current operator, and what are the features available. So these all the fields will be associated inside the asset. Okay, and for each stage of the life cycle, these field parameters will be changed while one transaction will happen. Okay, so what is the read set? Before doing that particular transaction, what is the current state of the asset? That is the read state. And after executing the chain code, there must be some change in the fields. Now suppose there is a transaction that, okay, I am changing the operator from A to B. I was in some operator A, now I am changing into the operator B. So the field of operator will be changed to B. So this is the write set. So that is the chain code. While the smart contract has been executed, then the assets, that particular state will be changed to a new state. The new state is called the write state, and the previous state is called the read state. Every endorsing peer will execute the chain code, everyone, and they will create the read-write set individually. After creating the read-write set, they will send the read-write set back to the application again, SDK. Then the SDK will send the read-write set, that batch of read-write set, to one of the service called the ordering service. Ordering service is not associated with any business parties or any of the transactions. It is the core of the blockchain technology. Okay, so ordering service is not associated with the business party. Now the ordering service will receive this read-write set. After that, it will send the read-write set to the committing peers. So the committing peers are also the peers from different business parties, means they will finally validate. So what they will validate? First thing they will validate that whether all the read-write sets is being achieved from the endorsing peers or not. Means the means whoever for this transaction to be mined, for this transaction to be logged, who are the endorsing parties available, and all the endorsing peers have executed the chain code or not. First of all, they will decide it. Okay, so they will check the endorsing policies, that is the validate endorsing policy, VSCC. After that, they will tally the read-write sets, that from all the endorsing peers we have different read-write sets. Suppose there are 3 endorsing peers, 3 business parties. A created read-write set, B created read-write set, and C created read-write set. Now the committing peer will tally that all the read sets are same or not. Yes, 3 read sets are same. Now they will tally all the write sets are same or not. Yes, whatever be the new state of given by A, it is same with B, it is same with C. This is the consensus. Now committing peer says that okay, so all the read-write sets are same from all the endorsing peers, and I have the endorsement, I have the read-write sets, the question paper and the answer from all the parties, so it is fine. Now it will actually log into the particular shared ledger. So that is the actually how the consensus has been happening inside the blockchain technology. Okay, so it is already 12:11. So let us move to the next slide. Next slide is the slide number 16. That is the private versus public blockchain. So mostly we will discuss about we have discussed about the private blockchain technology, because Hyperledger is a kind of private permissioned blockchain technology, and IBM is working on this Hyperledger platform. But apart from that, different public blockchain technology also available. Like one of the application of blockchain architecture is Bitcoin, another is Ethereum, and you can see different platforms are available over there, like IOTA and etc. So they are the public blockchain technology. But mostly for the enterprise level solutions, we prefer to use the private blockchain technology because it is more permissioned. And okay, so right now, okay, so so we have described about it, like what are the private and the public blockchain. So public blockchain example is Bitcoin, Ethereum, and other things. But most of them have this particular transactions, means the similarities over it, like both are decentralized and append only, immutability, consensus. The consensus protocols are different for different public and the private blockchain. Okay, so now one thing question may arise in your mind, that why it is called the chain, or why it is called the blockchain. So when anyone is appending any transactions into the shared ledger, okay, so it is actually appending like a block. You can think about a linked list or a some series of blocks which are connected to each other. So that is why it is called the blockchain. Suppose there one transaction happened, that I have given you $5, you give me 1 pen. So this is one transaction. So this transaction will be stored as a block at the last of the blockchain. So it is a kind of a linked list, you can see, and it uses one Merkle tree data structure internally. Means one of the tree data structure it has been using, but you can consider in a very high level that it is the chain of blocks. So once any transaction happens, it is included inside a block, one or many transactions together inside a block, and it has been appended. Whatever be the last node of that blockchain, it will be added at last to the blockchain. So adding work will be done by the committing peer. Okay, so like that. So you can consider it as a linked list. Okay, so next point is the difference between the public and the private blockchain. Sorry. One second. Yeah. Okay. There is some difference between the public and the private blockchain, that who is allowed to participate into the network and who is not. And public blockchain is open to all, anyone can see, which is not ideal for the enterprise level. And going to the next slide, it is for the Bitcoin. So one misconception is there that Bitcoin is the blockchain, but it is not. Bitcoin is one of the application of the blockchain, and blockchain is one of the architecture. Blockchain is the architecture, and Bitcoin is definitely one of the application of the blockchain technology, and which is the public blockchain technology, and it is associated with the cryptocurrency concept. Why blockchain is more secure? So it is the same, it has the replicated immutable shared ledger technology. So why immutable? Just in 1 minute I can tell that it is immutable because you can tamper it. You can tamper your ledger because you have your copyright, so you can tamper your ledger. You can go, you can change one transaction or something like that. But you can see whenever you will change any transaction, if you try to change the transaction, immediately your ledger will be synced with the other ledgers, because there always a majority happens inside the blockchain, that if it is like a PBFT consensus which is going on for the Hyperledger technology. So if you change or tamper your particular blockchain or any transaction you want to fraud, then you can see that immediately within fraction of seconds, again your transaction, your ledger will be changed, whatever be the majority of the ledgers are available inside the network. Okay, and the consensus protocol, definitely. So that is why it is more secure. You cannot cheat. The endorser needs to be endorsed, and the finality and difficult to hack. You cannot hack this particular blockchain technology, because while you will change one shared ledger, then after that, whenever you are going to change another shared ledger of another computer, then immediately the first ledger which you have changed immediately will be synced with other ledgers and going to the previous state. So same the Merkle tree data structure, whatever has been used inside the blockchain technology, you can see in the GitHub. GitHub uses the same thing. Whenever you will upload anything, you can see one transactional hash, one commit hash has been available. So the same methodology has been also used by the GitHub. So let's quickly go to the use cases. Okay, so now it is one of the use case of life science, like a drug supply chain management. So any kind of supply chain is really very useful, or really can be done in a very secure way using the blockchain technology. So in case of life sciences, the drug supply chain management is one of the very good use case, whatever you can think of or you can implement in your with your client, or you can propose, like you can create one small MVP over it, because it is the same, whenever this particular drug or particular asset, here what is the asset? Here asset is the drug. So first of all, you need to identify that what are the characteristics of that particular asset. And another thing in this context, if I forget, I want to tell that where the blockchain cannot be applied. So blockchain cannot be applied in such a system where the business network is small, only 2 or 3 business parties are involved, or only 2 business parties are involved. So in that case, blockchain is not an ideal use case. Blockchain is an ideal use case where the business network is big, and there is a lack of transparency between different business parties. You don't know what is happening there, and different business parties, there is a chance of fraud between them. So in that case is one of the major factor where you can think that yes, this is the use case of blockchain technology. So in the same thing, like drug supply chain management, different business parties are involved over here. You first of all, you have to identify the asset. The asset is the drug. Next, you have to identify the participants. that what are the participants involved inside this drug supply chain management. Okay, and after that you need to identify the transactions, that what will be the transactions between different participants happening. So in this way you have to identify it first, you have to first model, you have to first determine the data model, and using that particular data model you have to identify the transactions, participants, the endorsers, that for which transactions, who will endorse this particular transaction, who is necessary, how much permission I should give to which party, like that you have to first identify. So in case of life science, this particular practice, this public sector, this is one of the major use case, and I have written some points over here that what it is, and it is actually the provenance. So provenance refers to the ability to trace the origin and ensure the authenticity of the object being traded. And some counterfeit drugs continue to pose great challenges to the pharmaceutical distribution chain. So despite the improvements such as product serialization and e-pedigree, an electronic document that provides the data about the history of particular batch of drug, the problem of spurious drug continues to haunt the pharmaceuticals. So this is the burning problem. So this problem we have identified that yes, this is the problem. Now how we can actually overcome this problem using the blockchain technology? For that, we have to identify that how the consensus, how the provenance, how the immutability, that particular characteristics will help to solve this burning problem. If the problem is for the trust, if the problem is for the fraud, if the problem is for the lack of transparency, then apply blockchain. Try to implement blockchain over there, and the business party is huge. Then definitely that is the ideal use case of blockchain. So this is one of the point of the drug supply chain management. Next point is the cold chain management. It is somehow a variant of this drug supply chain management, but it is the temperature controlled supply chain. Definitely the temperature control supply chain, because there are different IoT devices are available. IoT and blockchain integration is definitely possible. So we have seen different use cases. I have worked on one of the use cases like airport baggage tracking, that particular use case. So in this kind of use cases, definitely we will get the notification, the events directly into the blockchain. Blockchain also have the capability to emit the events from their smart contracts. Okay, so we can actually see that where the drug, that particular drug has been tempered, or the temperature has been changed or something like that. So cold chain management in that way obviously is one of the burning use case, because it is a blockchain operating the cold chain can double as an early warning system. So it can provide you the warning in real time, directly in real time if you implement it, and side by side it will also serve as a thing of the supply chain management, that particular thing also. Okay, so let us go to the next another use case I have identified, that is the reverse supply chain management, because the lack of traceability in customer and the supply return process and involvement of multiple parties actually makes it very difficult to discover the counterfeit drugs, and lack of end-to-end visibility and transparency poses the challenge for everyone in the supply chain. So this is the problem. So this problem you have to first relate that what are the problem, whether the problem, as I have mentioned, of transparency, of fraud or something like that, and the business party is huge. Yes, reverse supply chain management in this particular case actually qualifies that all characteristics. That's why the reverse supply chain management for the counterfeit drugs is one of the use case which you can implement as a small MVP. Obviously, it is again associated with supply chain, but definitely it is more burning problem rather than the drug supply chain management, what I feel actually. Next point is the end-to-end serialization. It is the same thing, like one picture you can see that different business parties are available over here, and Yeah, and the pharma companies, the contract manufacturer, wholesalers, distributors. So these are the participants and government regulators. So different participants are available, and it is just I have mentioned because it is like a provenance over here. Okay. Okay, so it is 12:24, so let's go. Yeah, the last use case, that is the outcome-based pricing in the pharma industry, obviously. So here, a pharmaceutical company just entered a contract with the U.S. Centers for Medicare and the Medicare Service CMS that stipulates the payment for a new leukemia drug will be made only if patients respond to the treatment by the end of the first month of administration. So the cost of the medication approaches $500,000 for one-time application. So this is one of the outcome-based pricing of one of the use case over here. So how blockchain can help? You can see at the last line that the blockchain technology can help to manage this process by providing the trusted verification of the outcomes at the individual level. Okay, so means I will apply the drug to you, that particular drug to you, and depending on the outcome, I will go for the further treatment of it. But that particular outcome, we have seen that there can be some kind of misconception, or there are lack of different things available over here in the in this particular use case, because the net result is that you can see in the second line, the net result is the pay for performance pricing may increase immediate drug cost, but in long term it will reduce the patient cost. So all the provenance, it is basically the use case of the provenance over here, that what is happening to you right now for that particular patient, that can be logged inside the blockchain technology, and you can have a proper correct result. Okay, so this is one of the good use case. You can implement it. You can think of the architecture, the assets, the participants, the transactions over here. This is just the overview I have given. You can work on it. You can show the MVP to your client, or wherever be relevant, or for your practice, you can do it. So these are some use cases I have created, and two things I want to mention for the life sciences industry, that there are some problems associated which you need to take care from the architectural perspective. One is the legacy and the complex data, and the partnership and the ecosystem. So the legacy and the complex data means some kind of X-rays, MRI, these things, how to store the images. So one thing I can tell, that document upload is not possible inside the blockchain technology. How we actually consider the document upload? We create the SHA-256 hash of that particular document and store that hash inside the blockchain shared ledger. So like that, we provide the provenance of that particular document, because anytime if you do the same hash, it will give the same result. So as a provenance, we are doing like it. This is how the document upload has been possible. You can upload the document in your secure drive, or you can use the IPFS, that is the decentralized system. IPFS and Hyperledger integration is also possible. IPFS is one kind of decentralized storage. You did not need to pay the money for that. You can upload the document, but definitely the confidential document should not be stored over here there. So in this way, you can manage it. So these are the two problems. One is the legacy and the complex data. Another is the partnership and the ecosystem. Okay, so these two things you can identify as a problem while we're doing the blockchain architecture, but obviously in the production level. But using your expertise, definitely I'm sure that you can overcome it. Okay, thank you. So that's all for today. So if you have any question, you can type or you can ask. Yeah, so over to you.